Our next speaker is Helia Fathi from Iran, and the title of the presentation is Exploring the Impact of Samaritan on Infertility, Implication for Spermatogenesis and Hormonal Regulation.
Let me now introduce the main subject of my presentation. Today, I would like to share with you the findings of an experimental study that explores the effect of sumatriptan, a serotonin receptor agonist, on male reproductive health. It's a privilege to speak before such a distinguished audience. My aim today to present findings from a study that investigates whether sumatriptan, beyond its role in migraine therapy, can influence testosterone levels and spermatogenesis in male mice. Infertility affects approximately 10 to 15% of couples globally. In nearly half of the cases, male factors are responsible. One critical component is spermatogenesis, which is regulated by testosterone. Interestingly, serotonin pathway also interact with endocrine regulation, prompting us to ask whether a serotonergic drug like sumatriptan may in fact impact male fertility. This study aimed to evaluate the effect of sumatriptan on serum testosterone levels, sperm count, and testicular function using an animal model. The goal was to assess whether this common migraine medication could influence male reproductive health. We used 24 NMRI male mice randomly divided into 4 groups: control, sham, just solvent, low dose sumatriptan, 15 milligram per kilograms, and high dose sumatriptan, 100 milligram per kilogram. The drug was administered daily via oral gavage for 22 days. At the end of the treatment, samples were collected for testosterone assay and sperm analysis. Our finding revealed a significant increase in testosterone level in both sumatriptan treated groups compared to the control. The high dose group showed the most pronounced increase, suggesting a dose-dependent effect of the drug on testosterone production. We also observed a significant increase in sperm count, particularly in the high dose group. This supports the hypothesis that sumatriptan may positively affect spermatogenesis. The observed change suggests that sumatriptan may act through serotonergic pathways to enhance reproductive function. These results align with earlier findings about serotonin's role in regulating testicular hormones. However, other studies show mixed results underlining the complexity of the interaction. Our proposed mechanisms is as follows: sumatriptan active serotonin receptors influencing GnRH release and stimulating LH secretion, which in turn activates Leydig cells for testosterone production. Additionally, it may reduce oxidative esters, further supporting sperm health. In conclusion, sumatriptan increased testosterone levels and sperm count in a dose-dependent manner in our mouse model. While these findings are promising, further studies in human and across different models are essential before any clinical application can be recommended. I would like to express my deep appreciation to my academic mentors, the laboratory team, and the institutional support that made this study possible. Thank you very much for your time and attention.